Okay, so we're going to continue our study on dividing radicals, and again, we're focusing on square roots. And in this lesson, we're going to look at the denominator at a in problems where the denominator has two terms instead of one. So let's kind of review something from a previous lesson. So from a previous lesson, you were asked to divide, and so let's suppose we had negative 3 divided by the square root of 5. Okay? And so when you're asked to divide this, one of the things you need to remember is that you want your denominator to not have a square root in the denominator. So we use what was called rationalize the denominator, right? Okay, so you may remember that from a previous lesson. Rationalize the denominator. Now, notice that in this problem, you only see one term. Okay, we're about to focus on, well, what do we do if we have two terms? Well, if you have one term, then that's easy to do. What you saw is that to get this to be a rational number, remember the square root of 5 is an irrational number. To get that to be a rational number, all I need to do is multiply both numerator and denominator by the square root of 5, by that radical. And so then I get negative 3 square root of 5 divided by 5. And so there's your answer, because the square root of 5 and the square root of 5 is the square root of 25, which is just 5. Okay? Now, here's the situation though. What if, and I'm going to go ahead and write this as number 1 now, and then the directions will say rationalize the denominator, rationalize the denominator. Okay, it could say divide, keep that in mind. So if it says divide, you need to know that you don't want a square root in the denominator, so you're going to rationalize the denominator. But what if I had this though? What if I had negative 3 divided by 2 plus the square root of 5? So it's almost the same as this one, right? Except notice that I have a binomial in the denominator. So you may say, well, can you do the same thing we did before? Can you multiply both numerator and the denominator by the square root of 5? So the question is can you just multiply both numerator and denominator by the square root of 5? Will that suffice? That's a question, right? By the square root of 5. All right. Well, let's check and see if it works. Okay, so listen carefully. So does this work? Will this rationalize the denominator? Okay, so let's see. So I'm going to rewrite the problem over. And so you're saying if I use the approach here where I just multiply both numerator and denominator by that square root that I saw, will that work? Well, let's see. So I get this, right? All right, so the numerator is negative 3 square root of 5. So it's okay to have a square root in the numerator, you just don't want in the denominator. But be careful. The denominator is this binomial times this monomial here, times this one term. So if you distribute, because remember what you really have is this, you have 2 plus the square root of 5 times the square root of 5. So if you distribute, you get 2 square root of 5 plus, and then the square root of 5 and the square root of 5 is 5. So notice the denominator is still rational. Denominator is still irrational, right? It's still irrational. So that did not work. So let's think about this now. So let's go back and rewrite number 1. And so we're going to rewrite number 1. So I have negative 3 divided by 2 plus the square root of 5. Okay, so whenever you have a binomial, whenever you have two terms in the denominator, okay? When you have two terms in the denominator and one or both terms are radicals, you're going to use what's called the conjugate to rationalize the denominator, with two terms. Use the conjugate. All right, so let's talk about what the conjugate is. So the conjugate of, and then we're going to do some examples. So the conjugate of 3 plus the square root of 5 is 3 minus the square root of 5. So all you do is just taking that middle sign here and just changing it. The conjugate of 6 minus 2 square root of 3 is 6 plus 2 square root of 3. See, all you're doing is just changing that middle sign. Okay? The conjugate of the square root of 7 plus the square root of 5 is the square root of 7 minus the square root of 5. All right? And whenever, and listen carefully, when you multiply conjugates, you get a rational number. Okay? You're going to get a rational number or a rational expression. So for example, okay, so look carefully. Let's suppose we had 2 plus the square root of 7 times 2 minus the square root of 7. So those are conjugates, right? Those are conjugates. If I multiply them together, using the FOL method, let's see what happens. 2 times 2 is 4. Now, the outer and the inner are going to be opposites. So the outer is a negative 2 square root of 7. The inner is a positive 2 square root of 7. And what you notice is that whenever you multiply two expressions that are conjugate of each other, the outer and the inner will always be opposite. So those, when they add them up, will be 0, always. And then you're left with a positive times a negative is a negative, and then the square root of 7 times the square root of 7 is 7. So notice you have 4 minus 7, which is a negative 3. So you no longer have any square roots. Okay? So when you multiply conjugates, you end up with a rational number. So example 1, let's do this. Example A, example B. So let's do another example. If you have 3 square root of 2 plus 5 times 3 square root of 2 minus 5, let's see what happens. So those are conjugates. So 3 square root of 2 times 3 square root of 2 is 3 times 3 is 9 times 2. Square root of 2 and square root of 2 is just 2, right? So that's going to be 18. Y'all agree? That's 18? Okay. So first times first is 18. The outer, 3 square root of 2 times a negative 5 is a negative 15 square root of 2. 3 times 5 is 15. The inner, 5 times 3 is 15, is a positive 15 square root of 2. So remember, these are conjugates, so the outer and the inner always cancel out. When you add them up, you get 0. And then a positive 5 times a negative 5 is a negative 25. So you get 18 minus 25, which gives us negative 7. Okay? All right, so just remember that when you multiply two expressions that are conjugate of each other, you're just going to end up with a rational number. And so that's what we're going to do in number 1. So let's go ahead now and start looking at number 1. So number 1, the directions will say rationalize the denominator. Now you have to remember that when you have two terms, you have to use the conjugate. So negative 3 divided by 2 plus the square root of 5. Okay, so here we go. All right, now I'm going to write this over. All right, so you're going to multiply both the numerator and the denominator by the conjugate. So don't forget, by the conjugate. So the conjugate of 2 plus the square root of 5 is 2 minus the square root of 5. Okay, what you do to the numerator, you do to the denominator. So this is still equivalent to that, because this is 1 right here. Anything divided by itself is 1. Okay, so now be careful. So do the work here. So you're going to say negative 3 times this binomial, 2 minus the square root of 5. And then let's go ahead and FOL this out. So when I FOL this out, I get 2 times 2 is 4. The outer is negative 2 square root of 5, right? The inner is a positive 2 square root of 5. Now I'm going to say this. You may say, well, do I have to write this out if they're conjugates? I know the outer and the inner will always cancel out, right? Yeah, you don't have to put that, because you know that's going to be 0. If you understand pretty well that when you multiply conjugates, the outer and inner will have to be 0. You don't have to put that there. Now, you do need to know that the last, you're going to have something there. So a positive square root of 5 times a negative square root of 5. Remember, this is always going to be negative because remember, if you look at the conjugates, the last terms, one's positive, one's negative. So that's always going to be a negative right here. And then square root of 5 times square root of 5 is 5. This is 0. And so now let's go ahead and distribute. Go ahead and distribute. So you get negative. Well, actually, let's not distribute yet because I want to say this. Let's not distribute yet because this factor right here could reduce with what you have down here. So let's just do this first. So I have negative 3 times 2 minus the square root of 5 divided by, now 4 minus 5 is a negative 1. And now notice this negative 3 divided by negative 1 is a positive 3. So you get positive 3 times 2 minus square root of 5, right? So this right here is a positive 3. And now let's go ahead and distribute. So you get 6 minus 3 square root of 5. Okay? So 6 minus 3 square root of 5. Now, to be aware though, if you had distributed first right here, you would have gotten, I guess right here, you would have gotten negative 6, a negative 3 times a negative square root of 5 is a positive 3 square root of 5 divided by, and then 4 minus 5 is negative 1. But you don't want to, we remember from previous courses and previous lessons in this course, if your denominator is negative 1, you want to rewrite it to where it's just a positive 1. And so in other words, you're going to rewrite this to where it's going to look like this. So you're going to say negative 6 divided by negative 1 plus 3 square root of 5 divided by negative 1. And that's going to be a positive 6. Negative 6 divided by negative 1 is a positive 6. A positive 3 square root of 5 divided by negative 1 is a negative 3 square root of 5. And so you get the same thing here. Okay? All right, so that's number 1. Let's look at number 2. Number 2, let's suppose we have this. We have 7 divided by, all right, 7 divided by the square root of 15 minus the square root of 3. All right, now notice this time I have 2 radicals, but it's still 2 terms, right? So I want to rationalize the denominator. I don't want any square roots in the denominator. It's okay to have square roots in the numerator, but not the denominator. So that's why we're going to rationalize the denominator. So I'm going to go ahead and rewrite this over. All right, now remember, to rationalize the denominator, I've got to multiply the numerator and the denominator by the conjugate. 2 terms, think conjugate. And the conjugate of the square root of 15 minus the square root of 3 is the square root of 15 plus the square root of 3. And what you do to the denominator, you do to the numerator. Okay? So then I get 7 times the square root of 15 plus the square root of 3 divided by, all right, let's fall this out. Remember, there was the conjugates, right? Those are conjugates. So the square root of 15 to the square root of 15 is 15. The outer and the inner will cancel out. They're going to have to be 0 because those are conjugates. The outer and the inner are going to be opposites. Now let's do the last. A positive times a negative is a negative. The square root of 3 times square root of 3 is 3. So then you get 7 times the square root of 15 plus the square root of 3 divided by, and then 15 minus 3 is, what's that, 12? All right. And guys, you can leave your answer like this, or you can go ahead and distribute, because I cannot simplify 7 and 12. So you can say R 7 square root of 15 plus 7 square root of 3 divided by 12. Does not matter. Okay? All right, so that's number 2. All right, number 3. All right, let's suppose we had this in number 3. We had 4 square root of 7 divided by the square root of 7 plus the square root of 13. So 4 square root of 7 divided by the square root of 7 plus the square root of 13. Okay. Well, again, notice I have 2 terms in the denominator. I have at least one of them is a square root, so I've got to use the conjugate. So I'm going to go ahead and rewrite this over. All right, and so I'm going to say times, now the numerator and denominator have to multiply by the conjugate of the denominator. And the conjugate of the denominator is the square root of 7 minus the square root of 13. Okay, both numerator and the denominator. All right, now we're going to have a little discussion with the numerator. But for right now, let's go ahead and write the numerator as 4 square root of 7 times the square root of 7 minus the square root of 13. Divided by, all right, now, see, this times this, right? Okay, no big deal so far. All right. Now the denominator, those are conjugates. So, and you're gonna they both have two terms. So you can use the idea of that FOIL. But remember, since they're conjugates, the outer and the inner are opposites. So it's gonna be 0. So all you need to do is look at the first, square root of 7, so square root of 7 is 7, and then a positive times a negative is a negative, and then the square root of 13, the square root of 13 is 13. So I have 4 square root of 7 times the square root of 7 minus the square root of 13 divided by, and then 7 minus 13 is a, what's that, a negative 6? Okay, negative 6. All right, now listen carefully to this. A while ago I said you could have left the answer like this because that was 7 and then 7 and the 12 I could not reduce. Okay, but here you got to be careful. See, that's the square root of 7, and if I were to distribute the square root of 7 times the square root of 7, I can simplify. So yes, you do want to distribute here. So let's go ahead and distribute. So you get 4, the square root of 4 times square root of 7 times square root of 7. So look, you have this 4 square root of 7 times square root of 7, right? So that's 4 times 7, which is 28. So that's going to be 28. Put 28 here. That's this, 28. And then minus, and then 4. Now you got to remember the square root of 7 times the square root of 13. Square root of 7, square root of 13. Use your calculator. Now notice that both 7 and 13 are prime. So, and then when you multiply them, there won't be any perfect square other than one that will go into 7 times 13. So 7 times 13 is 91. So this becomes the square root of 91. So I'm going to go and put that here. So that's going to be equal 28 minus 4 times the square root of 91 divided by a negative 6. And you can leave your answer like this, all right, no big deal. But if you wanted to, and you see, it gets a little bit more complicated at times. You're like, well, how much do I need to reduce? Well, okay, so you'll notice that right here, the 4 and the negative 6, I could have reduced that to begin with if I wanted to. They're both divisible by 2. Over here, now you could leave your answer like this. I'll be okay with that because I did rationalize the denominator. But notice that 28, 4, and negative 6 are both divisible by 2. So this becomes 14 minus, and then 4 divided by 2 is 2. Square root of 91 divided by a negative 3, right? And so that could be the answer. You can write it like this. Or you can say, well, I'm going to go ahead and make that denominator positive. So I'm going to bring that negative up to the numerator. So all these signs are going to change because a positive divided by negative is a negative. A negative divided by a negative is a positive. So this becomes negative 14 plus 2 square root of 91 divided by 3. Okay? So either one of those is correct. But the main point was that I need to see that you're rationalizing and that you know that this times this is a numerator, and you're going to multiply the denominators out. You're going to get this, and then go ahead and distribute because you can simplify the square root of 7 to the square root of 7. All right, so go and distribute that. All right, number 4. Okay, so number 4, we have this. We have 6 square root of 5 divided by the square root of 35 plus 3. So 6 square root of 5 divided by the square root of 35 plus 3. Okay, so let's notice I have a radical in the denominator. And so I need to rationalize the denominators. So since those are two terms, I'm going to use the conjugate to do that. So square root of 35 plus 3. All right, so I'll multiply both numerator and denominator by the conjugate of the denominator. So the conjugate of the denominator is the square root of 35 minus 3. Okay? All right, so then I get 6 square root of 5 times this. So I get 6 square root of 5 times the square root of 35 minus 3 divided by, all right, let's multiply this out. Notice when you FOIL this, the square root of 35 times the square root of 35 is 35. The outer and the inner are opposites. Okay, so when those are conjugates, always know that. You see the outer is a negative 3 square root of 35. The inner is a positive 3 squared root of 35, that's 0. And then the last, a positive 3 times a negative 3 is a negative 9. So this becomes 6 square root of 5 times the square root of 35 minus 3 divided by, and then 35 minus 9 is 26. Okay? All right, so let's go ahead and distribute this right here. So I'm going to get 6 square root of, and then 5 times 35. So 5 times 35 is 175. Okay? Minus, and then 6 square root of 5 times 3. 6 times 3 is 18, so you get minus 18 square root of 5 divided by 26. Okay, simplifying the square root of 175. So I can simplify that because remember the square root of 175 is the square root of 25 times the square root of 5. And the square root of 25 is 5, so you get 5 square root of 5. And, oh, I'm sorry. Let's see. Square root of 7, excuse me. I apologize. 25 times 5 is 125. Okay, so 7. Okay, so that's what this becomes here. So this becomes 6 times 5 square root of 7 minus 18 square root of 5 divided by 26. And then 6 times 5 is 30. So you get 30 square root of 7 minus 18 square root of 5 divided by 26. Okay, now, you know you did all this work, right? All this work you've done. And if you wrote this, I'll give you the points for it. But I want you to notice, see that 30, that 18, and that 26? They're all divisible by 2. So let's go ahead and reduce. So you can write your answer as 30 divided by 2 is 15, so you can say 15 square root of 7. 18 divided by 2 is 9, 9 square root of 5, and then 26 divided by 2 is 13, right? So no, that's a true statement. I can do that because if you think about it, I can write this as this divided by the denominator and this divided by the denominator. And then when I reduce, look, 30 and 26, they're divisible by 2. 18 and 26 is divisible by 2. Okay? All right, so that's number 4. Okay, let's go to number 5. Number 5, let's suppose we had this in number 5. Let's suppose we have 3x divided by 4 minus the square root of 3. All right, so notice I have a square root in the denominator. I have 2 terms, so in order to rationalize this, I have to use the conjugate. So 3x divided by 4 minus the square root of 3, so I'm going to multiply both numerator and denominator by the conjugate. So I get 3x times 4 plus the square root of 3 divided by, all right, let's go ahead and rationalize the denominator. Multiply this out. 4 times 4 is 16. The outer and the inner will become 0. And so you have a negative times a positive is a negative, and then the square root of 3 times the square root of 3 is 3. So I get 3x times 4 plus the square root of 3 divided by, and then 16 minus 3 is 13. And then let's go ahead and distribute. So 3x times 4 is 12x, and then 3x times the square root of 3 is 3x square root of 3 divided by 13. Okay? And if you left it like this, I'd be okay with that, but this is probably what you would see as the answer. Okay? So that would be the answer that you would see. All right, so, okay, number 6. Suppose we had this in number 6. We had the square root of y divided by the square root of 7 plus the square root of 15y. All right, now looks more complicated, right? Okay, so you can handle this. You have square roots in the denominator. You want to get rid of those square roots. It's 2 terms, so you use a conjugate. So we have this. I'm going to rewrite this over. We have the square root of y divided by the square root of 7 plus the square root of 15y. So I'm going to go ahead and multiply both numerator and denominator by the conjugate. And the conjugate of square root of 7 plus the square root of 15y is the square root of 7 minus the square root of 15y. Just like that. All right. Now, be careful because you see how I said you could leave it like this because distributing it is not going to simplify anything further. But you are going to have to distribute here because you see that square root of y and then you have a square root of y in here. So you can simplify that further. So I get the square root of y times the square root of 7 minus the square root of 15y. Okay? Divided by, all right, let's do let's follow this out. Square root of 7, square root of 7 is 7. The outer and the inner, those are going to be 0 because those are conjugates. So don't even do the work. You know that since those are conjugates, the outer and inner will always be opposites. Okay, now a positive times a negative, let's do the last, is a negative. Square root of 15y times the square root of itself, right, is the radicand, 15y. And notice those are not like terms, so that's all you can do. So you see this right here? See how right here I could combine those because those were real numbers. So 16 minus 3 is 13. Here you have a variable expression. So this has a y, this is not. Those are not like terms, so leave it alone. That's all you can do. I would go ahead though and distribute. And so you get the square root of y times the square root of 7 is the square root of 7y minus. And then this is the square root of y. Think about this. Okay, go off to the side if you need to. The square root of y times the square root of 15y is the square root of 15y squared, right? 15y squared divided by 7 minus 15y. But you know the square root of y squared is y, so be careful. So you know, see this right here? You know that that's the square root of 15 times the square root of y squared, and square root of y squared is y, so it becomes y square root of 15. See, that's this right here. So you get square root of 7y minus y square root of 15 divided by 7 minus 15y. Okay? All right, so that's that. All right, so that's number 6. Okay, number 7. All right, let's suppose you had this in number 7. You had the square root of a minus the square root of d divided by the square root of a plus the square root of b. All right, so you have two terms in the denominator. At least one of them is a square root. In fact, both of them are. But since you have two terms, you're going to use a conjugate. So you multiply both numerator and denominator by the conjugate to make this a rational expression. Get rid of that square root. So I'm going to rewrite this over. All right, so you're going to say times the conjugate, the square root of a minus the square root of b, the square root of a minus the square root of b. All right, now be careful because you have a binomial. You have two terms, some two terms, two terms, some two terms. So let's go ahead and write it like this first. So in the numerator, you have the square root of a minus the square root of b times the square root of a minus the square root of b. The denominator, those are conjugates. So the out and the inner will be 0. So let's just look at the first and last. The square root of a times the square root of a is a. Now let's do the last. A positive times a negative is a negative. And then the square root of b times the square root of b is b. So my denominator is just a minus b. Okay. Now let's follow the numerator out. So I know my denominator is just a minus b, and I cannot combine those. Those are not like terms. Okay, now be careful. So you remember the denominators are conjugates. So the out and the inner will be 0. Here, those are not conjugates. All right, those are not conjugates. So you need to do first, outer, inner, last. You have to do that. Those are not conjugates. Okay, first. And let me go ahead and write it out right here. Square root of a minus square root of b times itself. Okay. Square root of a times square root of a is a, right? And then the outer, the square root of a times negative square root of b is negative square root of ab. Okay? The inner, negative b times the square root of a is also negative square root of ab. And then last, a negative times a negative is a positive, and b times b is b. So these are like terms right here, because they both have the same radicals, and the radicands are the same. The indices and the radicands are the same. So this becomes a negative square root of ab, and another negative square root of ab is a negative 2 square root of ab, and then plus b. So that's, and those are all different terms. So that's your numerator. That's your numerator. And that's all you can do. You're done. You can't do anything else. There's your answer. Okay? So yeah, it looks complicated. It is very difficult to do sometimes. Okay, let's do one more, and let's make this number 8. Number 8. Suppose in number 8 I have this. The square root of 10x minus 3 square root of y divided by the square root of 10x plus the square root of y. All right, so we have that. And so again, I have two terms in the denominator, and both of them have a square root. And so I'm going to use the conjugate to get rid of those square roots in the denominator. So I have the square root of 10x minus 3 square root of y divided by the square root of 10x plus the square root of y. So I'm going to multiply both numerator and denominator by the conjugate of the denominator. So remember, the conjugate of the square root of 10x plus the square root of y is the square root of 10x minus the square root of y. Okay? All right. Now, let's do the denominator first. The denominator, since those are conjugates, that's going to be the easy one to deal with, since those are conjugates. Because watch. If you go back to the one we just did, you see how we did this one? We did the denominator first. Since those are conjugates, you multiply that out, you no longer have a square root in the denominator. Okay, you have it in the numerator, which is fine. You just don't want it in the denominator. So that's why you multiply both numerator and denominator by the conjugate of the denominator. So when I multiply these two conjugates, the square root of 10x times the square root of 10x is 10x. The outer and the inner are going to have to be 0 because those are conjugates. The last, a positive times a negative is a negative, and the square root of y times the square root of y is y. And that's what you're going to get. So notice you no longer have a square root in the denominator, so you rationalize the denominator. Now you have to do some work here, though. Okay, so let's look at this. So I'm going to go ahead and write it out right here. So I have the square root of 10x minus 3 square root of y times this, the square root of 10x minus square root of y. All right. Now be careful. You have to do first, outer, and the last because those are not conjugates. So let's do the first. The square root of 10x times the square root of 10x is 10x. Okay, that'll be outer. Okay, think of, first of all, positive times a negative is a negative. Now think, the square root of 10x times the square root of y, right, is the square root of 10xy. So square root of 10xy. Now the inner. So let's think about the inner. So the inner, a negative times a positive is a negative, but you have 3 square root of y times the square root of 10xy. So when I multiply these two square roots, that becomes 3 square root of 10x. Let's see, that's just 10x, right? That's just 10x, the inner, excuse me. So that's going to be just 10xy, right? Okay, so that's going to be this, so minus 3 square root of 10xy. And now the last. So the last, now be careful, the last. A negative times a negative is a positive. I'm running out of room, so I'm going to put that right here. 3 square root of y times the square root of y. Okay? 3 square root of y times square root of y. So this is 3, and you know that the square root of y times square root of y is y, so that's just 3y. So plus 3y. Okay? Now I want you to notice, these are like terms. So you have a negative 1 and a negative 3. So that becomes 10x minus 4 square root of 10xy plus 3y. And that's all you can do. Those three terms are not like terms. So that's going to be your numerator, and that's your answer. 10x minus 4 square root of 10xy plus 3y. Okay? And be careful. Don't say I'm gonna reduce these 10x's, because 10x here and 10x here is not, those are not factors because of that subtraction right here. All right, so you got to be careful. That's your answer. Okay, that some of these can be pretty somewhat difficult to go through because of all that multiplying of radicals involved. But it's not undoable. You have enough information to be able to do these problems. But before we finish, one of the things, remember, you need to be able to, in this course, you need to be able to get to the point where you can rationalize something like this. So be able to do something like this. 2x divided by the square root of 3. Let's make it 3 plus 5. Okay, so if you can do that, then you're doing good with the intent of this lesson. So you're going to multiply both numerator and denominator by the conjugate. So that's 2x. Let me go ahead and rewrite this over. So you can say the conjugate of the square root of 3 plus 5 is the square root of 3 minus 5. That will rationalize the denominator. And so I get 2x times the square root of 3 minus 5, right? Divided by, and then these are conjugates, so when I multiply that out, the outer and the inner are going to have to be 0. So I just need to look at the first and the last. The square root of 3 times the square root of 3 is 3. 5 times the negative 5 is a negative 25. So I get 2x times the square root of 3 minus 5 divided by, and then what's that? That's a negative 22. Okay? But notice now, you see, I can reduce this right here. So the question is, how far do I go after that? Well, see, some textbooks, they'll leave their answer like this, although without distributing, I should say, although they will reduce. So I can reduce that 2 and that negative 22. So I'm going to rewrite this over. So 2 into 2 is 1, 2 to the negative 22 is negative 11, right? And then they'll rewrite it to where the negative is not in the denominator. So they're going to say, well, I'm going to put that negative, I'm going to write this as negative x divided by 11. So they'll say, well, that's going to be negative x times the square root of 3 minus 5 divided by, positive 11. And then, see, those are all, if you left it like this, I'll give you the points if you left it like this. But most textbooks, in terms of the answer, even though this is correct, you did rationalize the denominator, you do really need to reduce. And so in terms of reducing the 2 and negative 22, that's 1 and negative 11. And I'm just going to go ahead and bring that negative up to the numerator. But some textbooks will, that could be an answer, some textbooks will distribute that negative x. So you'll get negative x square root of 3 minus, a negative times a negative is positive, so plus 5x, all divided by 11. So just know that if this was multiple choice, test, you still have to show the work, then this could be an answer. This could be one of the choices, that would be the answer. Okay? All right, guys. So yeah, this can be difficult at times, and the reason it can be difficult is you have radicals that are being involved all over the place, and then sometimes you're not sure, can I stop here or do I need to go further? So you have that ambiguity at times as well. Okay, so that is going to be, let me go ahead and get that front page. So that is the lesson on dividing radicals, square roots with 2 terms in the denominator.